Hello everyone. Today I want to explain my homework for part 3. Write a lambda diagram languages to control piston and show field theme together. Let's focus on homework concept directly. This assessment has 4 main goals. First, learn the basic programming rules of Siemens PLC lambda diagram and how to use parts like contacts and crows. Second, make the start, stop, and self-locking control logic for the piston air cylinder. Third, understand how to do consimulation between PLC programs and fluid steam pneumatic systems. Fourth, know the connection between pneumatic parts and the PLC's input or output ports. First, let's talk about the basicals of lambda diagrams. First, basic parts. They include normally open contacts, like I0, Pi0 for the start button. Normally closed contacts, like I0, Pi1 for the stop button. Output codes like Q0, Pi0 for the piston's solid lever. And self-locking circuits put a normally open contact of the output crew next to the start connect, and it can keep power on after pressing start. Second, logical rules. Electricity flows from the lift bisphere through several or propel contacts, then to the crew and back to the right bisphere. It follows the rule of left to right, top to bottom. This page is the crew of the leader diagram designed for this assignment. The control is clear. Press the start button I0, Pi0. The solid lever Q0, Pi0 for the piston gets power. Press the stop button I0, Pi1. The solid lever loses power, and it should keep working after starting. That's the self-locking function. The leader diagram has 4 parts. First, the start branch with normally open contact I0, Pi0. It turns on when you press the start button. Second, the self-locking branch normally open contact Q0, Pi0 is next to I0, Pi0. When Q0, Pi0 gets power, it closes by itself to keep the circuit on. Third, the stop branch will normally closed contact I0, Pi1. It turns off the circuit when pressed. Fourth, the output crew Q0, Pi0 that controls the piston. Let's show the logical. I0, Pi0 closes, Q0, Pi0 gets power, Q0, Pi0's contact locks. Press I0, Pi1. The circuit loses power, Q0, Pi0 turns off, and the piston stops. Let's look at this video. First, create new project. And my project name is Piston. Piston control. And now configures the device. And new device. We use Siemens S7 Y1200. Now double click PLC tags. Now we need to tap the PLC tags. The first is start BTN. Its address is %I0.0. And the second is stop BTN. Stop BTN address is %I0.1. The third is the piston. Piston level. Its address is Q0.0. Now we change to program blocks. Double click min. In network 1, we need to add something. First, we add a start. Second, at the stop begin. Then and piston value. And link to another line. Now we need to click Start Simulation. Now we need to connect to the device. Now we find the software and load it. Then finish this form. This page shows how flow themes for the mathematical circuit matches PLC. First, part connections, limit switches S1 and S2 in flow theme linked to PLC's input ports I0, I0 and I0, I1. They match the start and stop signals in the later diagram. Soldered wafers Y1 and Y2 linked to PLC's output ports Q0, Y0 and Q0, Y1. They are what the later diagram controls. The logic of the phonetical circuit PLC's output Q0, Y0. Drivers soldered wafer Y1 to move to cylinder when limit switches are triggered. They set signals to PLC for feedback, making the control more accurate. Let's look at the video. Finally, let's summarize the key gains from these assignments. First, I learned the design logical of the start-stop plus self-locking ladder diagram and how to use basic ladder diagram parts. Second, I finished the simulation of PLC programs and fluid streams, phonetic system, and understood IRO mapping and the whole simulation process. Third, I made clear the control connections between phonetic parts like solder levers and limit switches and PLC ports. I achieved all the goals of these assignments. This is all my homework. Thank you for listening. Goodbye.